The smoke detector would cut power to the actuator and it would spring
y
the
le robo el
damper
aire.
close. If you had a high temperature, the fusible link would melt
No entiende que
and the shaft spring close
dale
the
editar,
blades.
cámbiale la fecha, la hora.
So when we start looking at applications, 80% of them are going to be quite similar to what we just looked at. All your modern dampers, the spring is in the actuator or it's externally you can see it. And you're just going to remove the old bad motor and the old spring and direct couple an actuator on it. So this would be typical. This is the Barber Coleman or the CBMA 220. They're no longer manufactured. The motor was non-spring. The spring is that white arrow. It's underneath the little housing there. And when you go to remove it, you have to remove the old spring as well as the actuator. So you'd end up looking like this. This is the same damper. So you just drop an actuator over the shaft after removing everything. And this is going to be a constant theme here among a few pictures. Just find the damper shaft, draw a couple over it, and now you've got a setup that looks like a modern damper. So here's your common Honeywell. Well, it's direct coupled right on that shaft. The spring is in the actuator, so there'll be no problem in replacing it. Now, the method two are the old dual spring motors, which is the most common dual spring damper. So you've probably got one spring for the fusible link and one for the actuator. So you're going to remove the old actuator and its spring, but you're not going to touch that internal spring. So on the left side, there's a shaft spring. Leave it alone. You don't have to mess with it. On the right side, well, you're not going to try to replace the motor and put a linkage on it. You're going to take off the old motor, linkage, and the bracket. You are going to leave the bearing. You don't remove any bearings. So between the fusible link arms and the external shaft, you've got a bearing in there. You don't remove that. It's needed for the shaft to rotate. So here again, we don't try to replace just that old motor. We're going to get rid of that screen door spring, the old motor. We're going to take the linkage and the cable off. And now you've got the damper shaft. The orange arrow points to it. And you're just going to direct couple right on that jack shaft. So you're simplifying and bringing it up to a modern standard. So springs easily seen. So that motor and spring assembly are just like a modern Belimo. You pull everything off and direct couple. The toughest part of it is in the anti-rotation straps so that you can connect it to back end. Another case, same thing. On the left side, you've got what looks like assembly, but you're not going to try to replace that old motor. You're simply going to go direct couple to the damper shaft. And on the right side, you can see that the old motor is there at the top. You can see it's sticking out. It made a nice space to mount the anti-rotation strap, so we didn't even remove the old motor. Then the actuator, when it's put on there, well, the damper shaft was short, so we put the clamp on the inside and mounted it there. Now the weird ones, the 20%, probably not that high a percent anymore, they used one spring for both the actuator and the fusible link. And in this case, you got to go add the manual reset primary heat responsive device. So typically the old motors were non-spring. and you had a shaft spring, and there was a fusible link. So the left arrow points to where the fusible link was located. You got to take it off to hold the mechanism together, and then you're going to unhook that spring. And then you go to the outside of the damper, and you have to add a heat responsive device. So it's a bimetal manual reset. They're commonly available from any of the damper reps or the Belimo B. AE could be used also. This was how Actuator did theirs, and there were a few other cases. The Actuator spring dampers, there were a lot of these out there. Every month I get one of these. They were complex, and they can be recontrolled, but they take a little bit of work. I'm not going to go into the details here, but the point being, over on the right side at the bottom, there's when the motor drove open, it pulled that spring open via the blade. And at the above it, this is a fusible rod instead of a fusible link. That rod would melt, and then the blade spring would pull the blades back closed. The pneumatic ones were very easy because they had a shaft extending. The electric ones need a little bit of and it's the one wiring diagram that should be memorized. It's fairly simple there. On the left side, you've got your smoke detector. It's very often a duct smoke detector. It could be a relay from an area smoke detection system. But you've got a normally closed contact. Power comes in from the left and goes to the smoke detector, then goes to the thermal sensor that's mounted on the damper. That's closed. And then the actuator gets powered and drives open. If you see smoke, that contact opens. If high temperature exists in the damper, then the thermal sensor opens and the actuator springs closed. So it's simply two switches in series. The actuator and damper are not connected to the alarm system or the firefighter smoke control system in the Chapter 7 damper, the 85% that are for containment. The alarm system is notified by the smoke detector. Torque requirements. This is always the big question that comes up. Here are the rules of thumb, and we have a list in every one of our instructions on our website that gives you torque. So at the top left, our little FSTF, well, it'll do about 50% of the dampers that are installed. We say that it's for less than square feet, 2 square feet. It has passed UL at bigger sizes, but given corrosion, duct shifting, and so forth, you're safe with 2 square feet. At the bottom left, the FSLF, well, about 30% of the dampers are between 2 and 4 square feet. So fully 80% of the dampers out there are the small dampers. Top right, well, between 4 and 12 square feet, we would say to go to our FSNF. It's past UL as much as 16 square feet, but again, corrosion, duct shifting, dirt, it's better to have more torque than you need. And then when you get to the larger multi-section dampers, which is about 5 to 10% of the market, we would recommend our FSAF or our big modulating actuator. You're not going to remember everything we say here, and it is a little bit too much information, the instructions. The other way to look at it is just to go with a torque requirement rule of thumb. This is more an art than a science because different manufacturers and different ages of dampers and condition uh, really causes you to have to use a little bit of judgment. But for a parallel blade damper, which most fire smoke dampers are parallel blade, what you're going to need anywhere from 4 to 7 inch-pounds of torque per square foot. It'll be nearer 4 for the smaller dampers, nearer 7 for larger dampers. And if you do have an opposed blade, well, they require less torque. So 4 to 5 inch-pounds of torque per square foot. Those are very safe rules of thumb. There are a lot of ifs, ands, or buts. For example, FSLF actuator, which is 30 inch-pounds of torque. Well, it'll pass UL 555S with a 2 foot high by 3 wide, but it won't pass a 3 high by 2 wide because the torque load starts to become higher as you get a taller damper. So the condition of the damper does need to be considered. If your static is above 4.5 inches of water column, go with more torque. If your velocity is greater than 2,000 feet per minute, then you're going to need more torque. And if you've got linkages that you're applying, sometimes the linkages translate to torque and change the torque curve so it doesn't, you don't get a nice 90 degree to 90 degree actuator to damper relationship. So you have to start to add a little bit of torque to adjust for the linkage. It's difficult to tell. And then anything over 12 square feet, you start to see more of a torque requirement than per square foot than for a smaller damper. But we do have all the rules of thumb and recommendations in our instructions. Pneumatic to electric, very common now. Top left there, you see a pneumatic actuator. It's got a bracket, and the damper shaft is just visible at the top of the picture. Well, we're not going to try to do anything other than simply take everything off and direct couple right on top of that damper shaft. We will keep the old base as a nice way to mount the anti-rotation strap. So the same damper there is over on the right side, and you can see where the actuator has been direct coupled. And the base below the actuator is the same as the pneumatic base that was there. Where to go get information? I think access to information is the most important thing. You can't remember everything. So the website is the belimo.us and then /fire smoke. That gets you to our retrofit pages and all kinds of instructions. And you might note that the instructions start with the name of the damper manufacturer. There are some specifics, although I would say 80% of the time it's the same old thing over and over. There is a cross-reference along with a lot of pictures of the old dampers. And then there are any number of specific instructions. So that website really can guide you through a lot. I'll take questions now. I know we won't get to all of them. If you do have any questions, there's my email address. I'm happy to answer anything. If you've got a specific retrofit, the part number of the actuator is not often helpful. I really would like a picture of both the actuator and then pull back and get a good picture of the damper. And that's for me or for any of our tech support people. They all deal with this.
Excellent. Thank you so much, Larry. We do have a lot of questions that have come in. If you do think of any right now, please type them into the question box. We will not get to all the questions today, but Larry will be happy to answer the questions as he gets them, and you will receive an answer via email. But let's take a couple since we have 1 or 2 minutes left, Larry. Can you repeat how often life safety dampers must be tested?
There are a few local variations calling for more often, but the NFPA 80 and 105 require every 4 years for commercial dampers, every 6 years for hospitals. And if they're in a smoke control system, every 6 months if they're dedicated, once a year if they're non-dedicated. So 4, 6, 6 months, 1 year. And that's the same for almost all your life safety equipment in a building, at least once a year for testing and making sure everything's okay.
Thank you. What permits are required for replacement?
Varies by jurisdiction. In general, this is considered a normal repair, and no permit is required to replace an actuator. And now, if you're going to get a job with 20 or 50, whatever number you feel comfortable with, I would call up my local building official or fire marshal and ask them if you need a permit for it. Pneumatic to electric replacement, you're going to need a permit. The other time you need a permit is if you're making any structural change. A lot of times there's big space constraints and you got to remove some drywall or any part of the duct to get access. Then you should get a permit if you've changed anything there. You should also get a permit if you've touched any fire alarm wiring. So if you're dealing with the smoke control system, a Chapter 9 application, you're going to need to retest that alarm system if you've touched any of the wiring. It might require a permit. It may just require what NFPA 80 and 105 say is leave a record on premises. And that's the general rule for almost all cities.
Okay, thank you, Larry. That's all we have time for today. I want to thank everyone for attending today's webinar, and also to you, Larry. Please rest assured that you will get your answers to your questions via email. And also, please join us for our next webinar, which will be on June 17th at 2 p.m. Eastern Time. And the topic will be Belimo's industry-leading retrofit solutions, presented by Steve Lopes. Thank you, everyone, again, and have a great day.
No, thank you.